Hello friends and welcome. I am here to talk to you today about calibrating your solar lab, which is our first assignment to do with the solar lab kits. You're going to need a few things for this lab to work. First, you're going to need your solar lab kit. Second, you will need some kind of light source. I'm going to be using the light on my phone. But you could also use, if you don't have such a thing, you could use any flashlight. You could even, in a pinch, use the overhead lights or a lamp that you could turn on and use as your light source. And you're going to need something with which to measure. I am using this piece of wood. It's just a regular stick. It's actually a barbecue skewer. It doesn't matter how long it is, so long as it is a stick or some kind of measuring unit that you can use consistently over the course of this project. So don't lose it. So, in order to calibrate your solar cell, what I mean by that is to tell how much voltage the solar cell produces under certain specific conditions. So you're going to take your kit out here, got all your stuff inside there, and the first thing I need you to do is open this kit up. If it's stuck together with tape, you can cut the tape open. You're going to take your solar cell. Now your solar cell has 3 separate cells. I'm going to describe these as the left, the right, the center, and the right cell. You'll notice that each one has a plus and a minus. And on the back, those pluses and minuses are replicated, and there are these terminal screws that can actually be removed by screwing them, unscrewing them, and taking them off. Don't lose the screws if you do that. Secondly, you're going to notice that there's down the center of this a little piece of plastic sticking out and another little knob there. What those are for is to connect up with the base, the stand. So you take this symmetrical shaped piece and you'll notice that it also has a little groove, right, and a little snap. And so what you do is you take the back of the solar panel and you place the slot over the clip and slide it in until it snaps into place. Now it's going to be locked down there. If you want to unlock it, you got to lift this little lever up and pull it away. But we're going to leave it locked for now. Then you're going to locate the stand base, which has these 4 holes in it. And again, you'll see it's got that center piece and a little triangle. So once again, we're going to line this up with the triangle side. I've got the triangle side up, so I'm going to put this side up and go sliding on it until it snaps. Now, delightfully, I have a little solar panel that I can stand up, and I can change the angle that it's standing at. So we can put it straight up to the sky, I can lean it this way or that way. It's a little bit loose. If you want to, you could take a screwdriver and tighten these screws up a little bit. It'll tighten it a little so it won't flop as easily. But for today, you're not going to need to do that. I'm going to leave this pointing straight up. And now it's time to just take the light source real quick and show, here's what we're going to be doing with it. We're going to be holding the light source up. Oh, remember I said don't lose your measuring stick? There we go. I'm going to hold the light source up above the solar panel at a specific distance. And that way we can get a reading of how much voltage it produces under this very specific condition. Now, the direction you hold the light source at doesn't matter that much because these aren't very well focused, so they're going to radiate light out in several directions. But you do want to make sure you're directly overhead and that you're pointed in exactly the 0 direction. So what you want to do to make sure that you know the angle this is at, and maybe one way to do this, a good way to do this, might be to place this facing perpendicular to your tabletop. It's a little tricky to get unless you flip the leg out that way. And to make sure it's exactly perpendicular, you actually can use a bubble level, which I happen to have one of on my phone. Every iPhone has this app. It's called Measure. And you can hold the phone up next to it and you see where it says -2 degrees. If I lean this way or that way, when it gets to 0 degrees, it's going to turn green. So I want it to stay right at that angle. If it's off by 1 or 2 degrees, it's fine. Don't worry too much about it. But let's see. So we've got, let's see. Get this organized right. It's turned red on me. I don't know why. So let me get this to 0 to 90 degrees maybe. Ah, it's measuring the other direction. Let me see if I can fix that. Crash the app. Try it again. There we go. So now it's going to decide, okay, I don't know which way you wanted to go, so let's go that way. All right, so I want to tip this up just a little bit, and now we're at a nice 0 degree angle. So now if I measure a specific distance away with my light turned on, I just hold the light straight up and down. Now I've got a good, solid, measurable reading of where the light is at. You can do it from above as well, but this might be a little easier because you may be able to like prop your phone up against something and leave it there without having to hold it in both hands. Now, let's talk about your voltmeter. This is going to be how you test the actual voltage. So the first thing we need to do is locate the probes. There's going to be one black and one red. I'm going to have pointy ends on one side and little insert plugs on the other. Take the black plug and plug it into the bottom hole that says COM. That's the common ground. That's our negative side. The red plug is going to plug into the middle hole that says V omega MA. So this is going to be used for measuring voltage, resistance, or amperage. Now we got our two probes. We can turn it on. You want to go to the DC voltage side. And I recommend going to the 2000 M or the 20. The 20 will measure in actual volts. The 2000 will measure in millivolts. So you have to divide by 1000 in order to get the actual voltage in volts itself. I'm going to suggest, make this easy on yourself, grab a pair of gator clips. What we need to do here at this point is connect these two probes up to the terminals on the back, but they don't just sit there. They won't stay. So if we use these gator clips, they're going to grab onto the ends of the terminals and the probes. So I'm going to take one red gator clip. I'm going to grab my red probe. I'm just going to clip it on there like that so it stays. I'm going to take the red side of this. I'm going to clip it onto the plus side of one of the cells. Now these can pop off if you're not careful. I think it's easiest, rather than if you come from the side, if you come at it straight on like this and grab it like that. And you call them gator clips because they look like an alligator mouth. And grab a black one. One end goes to the probe. The other end clips onto the negative terminal. So now I've got positive and negative terminals set up. I've got my probes ready. And I can take my voltmeter and I can see how much voltage is being produced right now. Now, of course, there is a tiny, tiny amount of voltage. I've got 0.06 volts. If I cover this over a little bit, it goes down because it's getting some light from the overhead lights. Don't worry about that. When you shine your light source on it, it's going to overwhelm whatever light was already there in the room. If you don't have a light source and you're just using the ceiling, you're just going to point it straight up at the ceiling like this. It's not great because you can see it's only 0.24 volts in my situation. That's not a whole lot of light. It's not a whole lot of voltage. It's going to make it harder. So if you can find a light source, whether it's a phone with a light on it or a flashlight or anything else, even if it's like a table lamp, it's going to be better. The more voltage you have, the more accurate your readings are going to be. Okay, so now this is, let me start actually with the other one. I'm going to start on the left side and work my way to the right. Remember I said there's three cells, left, center, and right. And I want to measure the calibration on all three one at a time. So I'm going to start on the left and work to the right because that's how we read books, at least here in the Western cultures. Other cultures read books in other orders. So here I've got my voltmeter where I can see it. And I'm going to measure the distance using my measuring stick. And here we go. So that is 0.69 volts. 0.7 volts, somewhere around 0.69 or 0.7. Now, if I put this in millivolts instead, what you're going to see is the same number. Point this straight up at the sky. Straight up at the sky. There we go. Like I said, you might want to tighten up the screws a little bit. you're going to see the same number times 1,000. So instead of 0.69, there we go, 0.69 or 0.7, it gets a little more precise, but it doesn't have a decimal place on it. That's all. That's the difference. So my left cell is 0.69 volts under my standard condition with this amount of light at that distance. Now, if I put the light source at a closer distance, it's going to be brighter, higher voltage. If I move it further away, it's going to have a lower voltage. That's why we need the measuring stick. If I change the light source to a brighter light, it's going to have more voltage. A dimmer light will have less voltage. So you want to use the same light source and the same measuring stick throughout. Next step, measuring the center. Pop off these two gator clips, move them over. So instead of that one, I'm going to measure over here now. There's the center one. Point it straight up or straight over on the table. Let's do it straight over on the table this time just to show how that works. It works just the same. I'm going to just measure my distance and place my light source right there. So my center cell is more powerful than my left cell. I'm getting now 0.89 volts or 890 millivolts, roughly. It's going to measure it in that thousandth place. It might wobble a little bit. Don't worry about that. That's why it's probably better to just do it in volts, because now we only get 2 decimal places, and that third decimal place that wobbles a little more, we don't have to worry about. So there we go, 0.87, 0.88. If it's going to wobble a little bit between the two, pick one. They're not very far apart. Just pick one and say that's my actual value. Lastly, I just got one more to do. I'm going to move these clips over to the right-hand side. And one more measurement. And this time I'm going to do it on the tabletop. I've been showing you, doing them to the side so that you can see the things happening. Let me do it on the tabletop this time so I can keep my phone straight up and down as well. Oh boy, my right-hand cell is nowhere near as good. It's only 0.59 volts, so it's not as bright of a cell, or not as powerful of a cell. Let me just double check that since it was so different. I'm going to try it with the straight up and down method. Technically, I would recommend use the same method whether you're going up and down, left and right, because it might make a small difference, but it didn't in this case, 0.59, 0.6. So I'm going to write down each of those three values, 0.68, 0.89, and 0.56, in the file, in the form that I left for you guys. Just a little flash of brightness for you there. Get this off of there. And then when you're done, you can either pull the stand apart so that it fits back in the box if you need to keep things in the box. If you've got little sisters running around who are going to grab your stuff, you can disassemble this easily enough. You just lift the, there we go. So you can see the lever here. You just pull that up a little bit and it'll slide right off. Right? Pop this lever up a little and it slides right off. So if you need to put everything back away after every session, I understand that. We all have had siblings. Maybe not all of us. If you keep everything in the box, your siblings shouldn't be able to mess with it so easily. But if you've got a safe place where you can keep your stuff, you might just leave it assembled. I'm going to take my gator clips. I'm going to put them back together. Make sure you turn your voltmeter off before putting it away, because otherwise the battery that's inside of it will die. That's the lesson. That's all you got to do today. Thanks so much. Talk to you later.